Here's a probability question, and one of the toughest things with probability questions is deciding what method to use, but fortunately in this question we're actually told that we're going to need to draw a tree diagram, and hopefully that will enable us to answer the last two parts of the question. So Jimmy and Alan are playing a tennis match against each other. Now I'll be picturing Jimmy and Alan playing their tennis match. It doesn't matter too much if we don't know much about tennis, and in fact knowing all the ins and outs of a game of tennis might confuse the situation slightly. What we do need to know we have been given in the question. So the winner of the match is the first player to win 3 sets. Jimmy won the first set and Alan won the second set. That's information that might be important later on. For each of the remaining sets, the probability that Jimmy wins a set, well, this depends on whether he won the previous set or if Alan won the previous set. So it seems that if he's just won, then he's more likely to win again, whereas if Alan won the previous set, then Jimmy's slightly less likely to win this time. It is not possible to draw a set. Okay. So to begin to set up this probability tree diagram, to illustrate the possible outcomes, we need to think about all the possible outcomes. Now, they're going to play these sets, and as soon as one person has won 3 sets, then they've won the whole match. So that means we've got at most 5 sets in total. So if we think this through, we could have 4 sets where they've got 2 each, but then on the next set, whoever wins is going to get a 3rd set, and so they're going to win the match. So the most they could possibly have to play is 5 sets. So if we set up our tree diagram thinking about the events, well, the first 2 events have already happened. We were told that Jimmy won the first set and Alan won the second set, so that's things that have already gone on. The bit we're interested in is what happens next. So we want to know about the 3rd set, the 4th set and the 5th set. So we can begin to set up a tree diagram. So we'll have, for the 3rd set, it could be won by either Jimmy or Alan, and I'm going to use J for Jimmy, A for Alan. Then after that, if we follow along this branch, we've got Jimmy could have won, and then if they play again, it could be Jimmy or it could be Alan. And if we go along the other branch, then that's where Alan won the 3rd set, and then it could be Jimmy or it could be Alan. Now, let's just think a moment. Using that information we were given, Jimmy has already won 1, and Alan has already won 1. So they've got 1 each. So if we were to go onto this branch along here, then that would mean that Jimmy had the 1 that was in the first set, and then the 3rd set and the 4th set, giving him 3 altogether. So the tree would have a branch that finishes there because Jimmy would have won in that situation. Likewise, Alan would have won if we think about him winning the 2nd set, 3rd set and 4th set, so actually that branch stops off there too. But looking at the other branches, Jimmy and Alan have both won a set, and then Jimmy and Alan won another 1 each. That means they've got 2 each, or likewise on this branch that would give them 2 each. So on those branches they need to play again, and that would be all of the branches that we need, because following any of those we've got to the 5th set, which is the most we could possibly need, and we'll have 3 sets won by someone by following along any of these branches to the end of the branch. So we can go through filling in the probabilities. Now remember, what we're given in this question is information about the probabilities of Jimmy winning a set. So the branches we should fill in first are the branches for Jimmy winning a set. So the probability of Jimmy winning depends on what happened in the previous set. So to begin with, we had Jimmy won, then Alan won. So Alan has just won a set, so for the next one, if Alan's already just won, probability of Jimmy winning is going to be 0.4. So then we can look at the other branches. So if we look at, for example, this branch, then Jimmy has just won, so that should be a 0.7 probability, whereas on this branch, Alan has just won, that will be 0.4 again. So looking very carefully at all the branches for Jimmy winning, they're either 0.7 or 0.4, depending on whether they are coming after Jimmy winning or after Alan winning. The rest of the diagram is easy to complete because whenever we have a pair of branches, there are only two possible outcomes. So if Jimmy doesn't win, then Alan must win. So these probabilities have to add up to 1. So 1 minus 0.4 would give us 0.6 on this branch. We can do this for all of the branches that are left, filling in Alan's probabilities so that any time that we have a branch that splits, the two probabilities add up to 1. We now need to find the probability that Alan wins the match. So we can look at the branches where Alan would win. So bearing in mind that Jimmy and Alan both won a match, or rather a set, to begin with, then we need to look at the branches where Alan wins 3 sets, and that will mean that he's won. So Alan has got 1 set. He could then let Jimmy win 1, and then Alan would need the final 2, so that he would get 3 altogether and he'd be the first one to get to 3 sets. Or we could follow the branch where Alan wins, he's already won 1, remember here, and another 2, that would straight away get him to win with his 3, or we could have the 1 to begin with, another 1, then Jimmy, then Alan again. The other branches Alan wouldn't win because Jimmy would end up getting the 3 sets before Alan does. So to calculate the probabilities, we need to have the first 2 sets have already been played, and then we want, for example, on this top branch, we need Jimmy to win, and then Alan to win, and then Alan to win. So we multiply along the branches. That will give us the probability of this scenario where Alan wins. Or we use another branch, and when we have or, we add up the probabilities. So our probability of Alan winning is going to be made up of the probabilities along this first branch, so 0.4 multiplied by 0.3 multiplied by 0.6, then or, so we add on the probabilities along the next branch, so 0.6 multiplied by 0.4 multiplied by 0.3, and finally we can add on the last branch here, so we've got 0.6 multiplied by itself, so 0.6 squared. Now typing that onto the calculator, if I notice that these two are actually the same, it will be easiest for me to type in 2 times 0.4 times 0.3 times 0.6 and then add on 0.6 squared. This will give me 0.504. We're ready for the very last part now, which is to find the probability that the match ends after exactly 4 sets have been played. Well, looking at our tree diagram again, that's this scenario where we get to 4 sets and Jimmy's won, or this scenario where we get to 4 sets and Alan has won. So to calculate that probability, we use those 2 branches. So going along the top branch here for Jimmy and Jimmy again, that's 0.4 multiplied by 0.7, or we could follow the Alan branch, which is 0.6 squared. So adding up those 2 options, we end up with 0.64. On the mark scheme, we can see that even if we got the tree wrong, we'd be able to pick up some follow-through marks for using our tree, even if it was incorrect, but using it correctly to get the method marks in the last 2 parts. So the first part, it was really just 1 mark for each column being correct. So the bit that I'd labelled the 3rd set, 4th set and 5th set. And it does say that we can ignore anything before the 3rd set. That would be a common mistake, that people would think you needed to draw the branches for what went on in the first 2 sets, but we were given information about those, so all we were really interested in was what happened in the 3rd, 4th and 5th sets.